Bonjour class, comment ça va? Welcome to lesson 7.3, volume of three-dimensional shapes. Just remember that the volume is the amount of space that an object occupies. Okay? For prisms and cylinders, the volume can be found by multiplying the base area by the height. So if you already know the area of the base, just times it by the height. Then you need to be careful of when dimensions get doubled or tripled. We'll do an example here in a sec. But if all three dimensions are doubled, then the total effect is an increase by 8 because, for example, it's going to be 2 in one direction, 2 in the other, and 2 in the third to give you 8 times the effect. Let's take a look here at this example to explain it. Find the volume of a 1 centimeter cube that has doubled its dimensions. So let's take a look at the original volume. So if I quickly draw my lovely little cube, see if you have some better artistic talent than I do, and I show it as a cube, okay, and I know that it's 1 centimeter. So volume of a cube, you could either say that it equals length times width times height, which is your general volume formula for a rectangular box. However, you could also say volume of a cube equals S, meaning the side length cubed. Okay, so I'm going to plug that in, 1 cubed, which equals 1 centimeter cubed. Okay, now if I take that volume and I double each dimension on my box so that now each of these are what we call 2 centimeters. Okay, volume of a cube equals side cubed, which equals 2 to the power of 3, which equals 8 centimeters cubed. Okay, so what they wanted to know is what was the effect by doubling, because we had to double both in the width, the length, and the height in all three dimensions. That became 8 times the effect. Okay, so if I asked you to do an increase in volume, so how did the volume increase? You would take the new volume, new V, divided by the old V, meaning old volume. So it'd be 8 over 1, which equals 8 times. So it's 8 times as large. Okay? We'll do another example here just to try to fit that in. Okay? Example 1. Determine the volume of, for A. Determine the volume of the triangular prism. Okay, so taking a look at A, okay, first thing I have to do is look up the formula, okay? Or you could take a look and say, hey, let's let my base be this triangle, okay? So volume of the, do a little shape if you want, okay? Or you could write down volume of the triangular prism equals, I'm going to say base times height divided by 2, and then I'm going to times it by its length. Okay, now what dimensions do we have? Do we have the length? Yes, we know the length equals 12. Okay, we know that the base of my triangle equals 6 centimeters. But do we have the height, ladies and gentlemen? No, we don't. So we're going to have to find the height. So height in this case, if you take a look, the height is going to be this right here. So we're going to have to drop that and do Pythagorean theorem. So height squared equals the hypotenuse, which is 6 squared, subtract 3 squared, which is half of this base, if you're wondering where I got that from. Okay, so plugging that in, that's 36 subtract 9, which is 27, and that's h squared. Don't forget to take the square root of both sides, so h equals 5.2 centimeters. Let's plug that in. So what do we now know? We've got 6 times my height, which is 5.2, all divided by 2 times 12. Okay, plug it in your calculator, or you could do a cancellation quickly. You could say, hey, 2 goes into 2 once, it goes into 12 6 times, then you're multiplying less. Okay, so doing that, ladies and gentlemen, you should end up with 197.2, and what's our units here? Centimeters cubed. All right. Now it says B part, determine the volume if all dimensions are tripled. So I'm going to pretend that it's this big, but I'm going to just try to draw it a little bit bigger. Okay. So what do we know now? If we're tripling it, this is no longer 6. This is now going to be what? 18 centimeters. And I'm just going to put little dots so you know that. And instead of 12, that's going to be 36. Oopsie, let me fix that up. So that's going to be 36 centimeters. Okay, so the volume formula is still the same. Okay, so volume equals, we know our base is 18. Okay. Do we know the height yet, folks? No, we're going to have to find that. So let's leave it blank for one quick sec. And we're going to times it by the length, which is 36. Okay, so down below here, I'm going to drop the height here so we can figure out how do we find this. So we're using this triangle, which is a 90-degree triangle. That's why we use Pythagorean theorem. So to find h, we say h squared equals the hypotenuse side, which is 18 squared. Subtract half of the base, which is 9 squared. Okay, plug it in your calculator. You should get, for h squared, 243. Take the square root of both sides. H equals 15.6 centimeters. You do need to show where that height's coming from if it's not given. That's a required step. Okay, so now we can sub in that that's 15.6. Could do a cancellation here. 2 goes into 2 once. It goes into 3618. And then you just plug her in your calculator, ladies and gentlemen. You should get 5,054.4 centimeters cubed. Okay. Now let's just make one quick note here. How about we take a look at the volume increase? Okay, so volume increase equals the volume of the old, of the new, divided by volume of the old. Okay, so my new volume was 5,054.4. Okay, my old volume was 187.2. And if you divide those through, ladies and gentlemen, that's going to equal 27. So therefore, it is 27 times as large. Where does that actually come from, folks? Well, if you triple the base, you triple the height, and you triple the length, 3 times 3 times 3 equals 27. So it makes sense. Okay? Just remember that volume deals with 3 different dimensions, even though it's kind of confusing when we're dealing with some circles or cylinders or cones. But there still is a 3rd dimension there. All right, let's move on to another one. Here are some basic conversions for volume. Sometimes you have it in cubic measurements, and sometimes you have it in liters, which is also a liquid kind of volume, okay? All right, so let's take a look. Again, you could find any of these basic conversions on the website or on the formula sheet, okay? Not all are in one spot, actually. You just got to kind of look for the one we're looking for. So let's take a look at this example. Bobby Joe's pride and joy is his Chevy truck. So Bobby Joe has a Chevy truck, and he's got a small block 350-inch cubed motor. Okay. On the other hand, Robert Earl bets Bobby that his brand new set his brand new set of teeth, that his Dodge Hemi with 5.7 liter engine is bigger. Who gets to eat tonight? I.e., who wins the bet? So let's just start with Robert Earl. Let's compare his. You could go the other way as well. I'm just going with what was given. So Robert Earl has a 5.7, and that's liter engine. And what we need to get it to is to inches cubed. Okay, so I'm going to set up the equivalent fractions. I'm going to look for, in our formula sheet up here, notice that we've got 1 liter equals 61.02 inches cubed. You got to watch your units to make sure it's cubic inches. Okay, so the 1 liter goes under the liter column, and the 61.02 goes over there. So cross multiplying, excuse me, excuse me for sneezing there. When you cross multiply, you're going to get x equals 347.81 inches squared. However, remember that with math, ladies and gentlemen, when you're in imperial, round that to a fraction because we don't use decimals in imperial. So I got 13/16 inches squared. And who won the bet? The Chevy engine is bigger because it's 350 inches cubed as opposed to 347. That means that Bobby Joe gets to eat tonight. He's got to share the teeth. That's kind of crazy, but anyway. All right. Last question today, and this is an important one, and I've had to do this in the past, ladies and gentlemen. Deals with gardening. It's a very practical example. Okay, a garden has the following dimensions. Determine the amount of soil required to fill this bed. Okay, so pretend we're making a veggie garden or something. Amount of soil, hopefully you recognize as volume. So volume of the garden is going to equal the length times the width times the height. Looking at our diagram, ladies and gentlemen, hopefully you notice something sticks out. Well, you've got 5 meters here, you've got 12 meters here, but you've got 10 centimeters here. Remember, in order to do volume or area or perimeter calculations, all the units must be the same. So I've got to convert 10 centimeters to 0.1 meters. Okay? So when I sub that in, I'm going to go 12 times 5 times 0.1. Okay? Plugging that in, I have 6 meters cubed. Okay, so I need 6 cubic meters of soil to do my garden. Okay. Problem is, you get to the store and you say, hey, can I get 6 cubic meters of soil? But they'll say, hey, our soil is only sold in bags that are 1 cubic yard. So how many bags are needed? Well, what's the problem is, folks, is that this is in meters. The volume we've calculated is in cubic meters, but we need to get into cubic yards. So we have to use a conversion. Okay. So the conversion, I'm not sure if it's up top or if it's, let me just see if it's up top. Okay, so we've got 1 cubic right there. We've got, I'm just double checking here. Right here, we can use this measurement right here. Okay, so let's just revisit that. So it's 1 meter cubed to 1.131. I might have to come back to that. So let's do the conversion. So I'm going to convert meters cubed to yard cubed. Okay, so what do we know? We know we've got 6 over something equals x. Okay, so we know 6, which is 1, and I think the yardage was it 1.31, folks? Sorry. Yep. Okay, cross multiply, ladies and gentlemen, and you should get that x equals 7.8 yards cubed. Okay, so that means that's how much we have in yards. Do you think you can go and buy 7.8 bags? No. So you're going to say round up. So therefore, we need 8 bags of soil. Great. Here's your homework, folks. Page 144 to 143. Numbers 1AB, 2AB, 4, 8, 15, 16, and 21AB. Have a great day and namaste.